Let's talk about the options that we have for choosing u in this integral. It seems like maybe one option would be to choose u equals 1 over x squared. The problem is, if you rewrite this and then take a derivative, you get that du is negative 2x to the negative 3 dx, and that doesn't appear anywhere in this integral, and I think it's kind of taking us in the wrong direction. So we're going to take this option off the list. You might think that another option would be just choosing u equals 1 over x. You'll notice I'm mysteriously leaving some space here, but if we chose that as our u, we could rewrite that as x to the negative first power, and then du is negative x to the negative second power, and that term 1 over x squared appears right here in our integral, so that is great. That's what we're looking for. But I think our lives would be a lot easier if we could just choose this whole thing under the square root for our u substitution, and that's what we should do, because if we put our 1 plus here, it does not impact our du. The derivative of 1 is just 0, so we have a better substitution for our u, and we still have the du that we want. Okay, so making the substitution, you'll notice that this here is your u, and that this 1 over x squared dx is going to be negative du. So our integral becomes the square root of u times negative du, which of course is just negative square root of u du. At this point, I'm noticing that this is a definite integral, so we should talk about our limits. When x equals 1, that's our lower limit of integration, u is going to be 1 plus 1 over 1 using our u substitution up here, which is just 2. When x equals 4, u is going to be 1 plus 1 over 4, which is 5/4. Now those aren't the best limits I've ever seen, but let's go ahead and put them in. Our lower limit of integration now is a 2, and our upper limit of integration is a 5/4. Now to integrate this, it would be helpful if we could just rewrite the square root of u as a u to the 1/2. That lets us see a little bit more clearly that we're going to be using the power rule for integration, which says we need to add 1 to this power, making it a 3/2 power, and we need to divide by that same power, and we're going to evaluate from 2 to 5/4. A little bit of simplification, and then we can use our fundamental theorem of calculus, plug in our upper limit of integration, plug in our lower limit of integration, and this just looks like a mess of numbers that's going to give us something irrational. So if we're going to plug that into a calculator, just keep in mind that this fractional power here, this 3/2 power, is going to have to be in parentheses. This minus a negative turns into a plus. So if you type all of that into a calculator or into Google or Wolfram Alpha or something like that, that's going to give you a number. And in my example, that number is approximately 0.9539. Okie doke, I hope that helps.